Start.
All right. Good evening. Welcome to the June 2026 meeting of the St. Louis Java Users Group. Thank you, folks, for making it out here. I know there's a storm coming, so I appreciate you all braving the severe thunderstorm watch that we're under, and hopefully we can all make it out and get home safely tonight. We appreciate you being here. Appreciate everyone who's joining us online as well, including our speaker. I'll get to that in a minute. For anyone who's new, the St. Louis Java User Group was founded in 1997, so we've been around for a good long while. Attendance is free, of course, so open to the public. Anyone can join. There's no formal membership, and we typically meet the second Thursday of the month, excepting for December. And food and social time starting at 6, with the official program beginning at 6:30, and our normal meeting location is right here. You made it. If you're here in person. Otherwise, you found the meetup link. So good on you. But we meet here in the OCI training room. I work for OCI, and they're one of the sponsors of the Java User Group. So we appreciate that as well. The steering committee that kind of stewards the group consists of myself, as well as Bruce Alspaugh, Robert Levitt, and Todd Doyle. Robert's here with me here in the room, and Ted and Bruce are online. And you can reach all of us at the Google Groups email address there at the bottom of the slide. So please feel free to get in touch with us if you're interested in presenting or sponsoring or helping out on the steering committee. We could use some help there. Please feel free to get in touch with us. We want to thank our sponsors. I already mentioned OCI that sponsors the training room. It gives us this space free of charge. We very much appreciate that. Also, Manning Publishers and JetBrains are both longtime JUG sponsors, and our friend Lee Bobbitt sponsors our Meetup subscriptions. We're very grateful for that. Couple of announcements. Kansas City Developers Conference is coming up September 9th through 12th. Early bird pricing is still available, so do take a look at that if you're interested. It's not too far of a trip from St. Louis. We have a long-standing discount code from Manning, as I mentioned previously. 45% off any Manning ebook purchase with the STJUG45 discount code. So thank you again to Manning for that. Upcoming presentations. Next month, we have a presentation by Sam Gammon on Elide. I'm not too sure how to pronounce that one. All-in-one native tooling for the JVM. And then James Fredley out of North Carolina is coming out in August to give a presentation on Apache Grails, which is something that if you've been around St. Louis, you've been around OCI for a while, you know that we have a long history with the Grails framework, now the Apache Grails framework. And James is going to be bringing us, should be a fascinating presentation on what's new with that. And you can find information on upcoming presentations on our meetup.com page there, Gateway Jug. And these presentations are recorded, and you can view them at our YouTube channel, which you can see there is Bruce's YouTube channel. And again, please get in touch with us, with any of us on the steering committee if you're interested in participating with the JUG. So, keeping it short and sweet tonight so we can wrap up and get home before the storm hits. Our speaker tonight is Karthic Kathari, and he's giving us a presentation on Model Context Protocol, MCP, Deep Dive. So, Karthic, are you ready?
Yes.
All right, I will end my screen share and you can start up yours and we'll jump right into the presentation. Thank you, sir.
Awesome. Thanks. Okay, I'm guessing you can see my screen and the slide deck.
Yes, we can. It's a little blurry.
Awesome.
If you could zoom in a bit, that might help.
Awesome.
I can see it and hear it. Yes, I think over time it kind of gets sharper as the network adjusts.
Awesome. Okay. So I'm Karthik. I work on full stack. I work for Build.com for last year. I've been working with Build. Before that, I was with Overstock, Bed Bath and Beyond. So at Build, last 6 months, I have been working on agentic solutions, like the harness-based workflow for agentic development and developer productivity. And we have been working on few MCP solutions internally and externally. So This talk would just be a deep dive into model context protocol, why, what, how, the history, and the foreseen future of how it might be evolved compared to the skills and also the CLI versus MCP, etc. So before we jump into the deep dive, just talking about the history of MCP and why MCP was into the picture. So I guess it was sometime in 2024 or late 2023 when ChatGPT had published their API out, integrating ChatGPT APIs into internal tooling systems like maybe a SQL database, etc. Was a nightmare because the API was constantly changing and integrating with one. Then later came out Claude and Gemini and other LLM solutions. So scaling the implementation of integrating tools with LLMs across different LLMs and different tools has been a nightmare. So that's where you see this problem of multiple LLMs integrating with multiple toolings, where you need to have custom implementation for each of the tool via each LLM. So that's where, and the other problem was tying to the solutions. The reason you need custom solutions was not just the implementation, but it's like any other backend implementation where you need a proper abstracted data mapping, and you need a proper parsing layer to parse different responses, whether it be JSON or XML, tied to different LLM providers, and each LLM providers has their own strict schema, etc. So handling all those things wasn't easy, and maintaining all that is a nightmare. And on top of that, the security for different toolings is different. So SQL provides a different security, and when you're connecting to a SQL database, there might not be OAuth into picture. You might have to handle the username, password. Some databases might not have client secrets or API keys, etc. So handling different kinds of authentications, and then the authorization is its own bottleneck. Most of these toolings don't have authorization layer into the picture. So taking all this into consideration, that's where MCP came into picture. So Claude, I think, was the one that pushed out MCP, and MCP solves most of these issues. So it solves this and this N by N through having this standard protocol. So MCP protocol is kind of twofold. They kind of have this data layer protocol and transport layer protocol. On the data layer, they kind of use JSON RPC. So they standardize upon the request response payloads to an extent. And then for the transport, they have like two options. One is if the MCP is running on a local box or on a server, through STDIO, that's one means, and second being streamable HTTP. So the data layer and the transport layer. So the streamable HTTP, where the communication can just be over HTTP. So, and jumping into the payload structure, on the data layer, the standard around the payload is every MCP call. Let me jump into this in a second. Before that, I'll pull something up. Okay, MCP lifecycle. So as part of the lifecycle, MCP client. So think of so there are like three components: host, client, and the server. Host is nothing but something like your ChatGPT or Claude Code CLI, something like that. And client is an instance of MCP client that's instantiated for every one-to-one connection to a server. So the host, which is in this example, let's pick the Claude Code. So Claude Code or just initiate a client, MCP client, and establish a connection between the client and one of the MCP servers that it's trying to connect. If there are n MCP servers, it initiates n different clients and initiates the connection one-to-one between the client and server. So as part of this client server initiation, there is this initiation steps that happen, which is the HTTP call or STDIO calls that happen. So your client would send an initialized request and server would respond with what are all the capabilities that it supports. As part of the protocol, server to host communication would could at most support like three different capabilities or the primitives. So one being the tools, resources, and prompts, and similarly client to server, the bidirectional communication could also happen, and client supports could support each one of these three primitives. So jumping back here, as part of this initialization, once the request is initialized, server would just respond with what all it supports, tools versus resources versus prompts. And then the client would just go acknowledge that. And then as part of the operations, if the client wants to know list of all the tools that are provided by the server, list of all the resources, list of all the prompts, it makes appropriate calls to get that information back. And then based on the call, now your client, which is your Cloud Code, the host that's maintaining this client, has information of all the tools and the resources and the prompts. Now, based upon user's prompt within the session, the host, in this case, the Cloud Code, can make appropriate call, which is again probabilistic, not deterministic. Appropriate call, it would pick appropriate tool and make a tool call to the server, triggering a function, whatnot, etc. on the server side. So that's where we now. So that's where we kind of jump into details of each of the primitives. Let's go into details of the primitives, and after this, I'll just share an example that I worked up. So as part of the primitives, tools is pretty straightforward. If you look at tool as your server to host, your server is responding to a request, and it's kind of triggering a function call. So a tool would look like this. So you define a tool saying, okay, create a GitHub PR or GitLab PR, and you have your description. The description of your tool is very crucial. So your description helps an LLM to decide when a tool should be triggered. So description is the most crucial piece. And then you can define the schema for this tool. Based upon the schema, your LLM would know what fields are relevant and required to be sent as part of this tool call. And then you have asynchronous operation, which is firing a function. And then the request response on the wire would look like this. So very first step, your LLM would trigger this list all the tools. So it will get list of all the tools, one being this create GitHub PR. And then based upon this information, your LLM, when appropriate, would go trigger the tool call, would go invoke this tool via tool call. And then it's invoking it based upon the name, based upon list of tools, it'll pick this tool and say, pass in all the arguments. And then your server, MCP server, would just perform the function operation and then just respond. So as part of the response, you can have it be structured as well. So this is the input structure and this is the output schema structures of these. And then based upon the structure, you have your result popped out. So that's the tool call. So easy way to remember is tool call is tied with like two crucial primitives, one being tool list, another being invoking the tool, which is the tool call. Both are triggered from the client, the host, which is the Cloud Code, to the server, and the server is just responding in both cases. And tool is nothing but a function. So it triggers a function, and the function is some operation that the function on the server side could just go trigger an API, or could just go do some business logic, or could just go handle some auth operation, or could do some DB operation, etc. And then the second piece being resources. Resource is the file or a resource that your server wants to share with the client. So it's similar to tool call. The operations are list resource, and then so resources are twofold. One is general resource, one is template-based resource, which has some placeholders. And then the next being reading or extracting the resource. Resource is just a read operation. So getting the resource. So yeah. So the tool versus resource. Resource can also be replaced with a tool, but the reason resource is in place is avoiding the network call. So the very first time when resource list is being triggered from client to server, your server is responding saying, okay, you as a client or an LLM have access to these resources. So you can straight away go access this resource. So that's how your LLM knows what resources it has access to, and it makes that call of when to go fetch that resource and read the resource. And then prompts kind of help to set a workflow, like a predetermined workflow, and it helps to guide an LLM follow a particular path or a workflow. Again, prompts have the same style. So the very first thing your client triggers is give me a list of all the prompts available. So in this case, one being, okay, review a PR. In order to review a PR, pass me the PR number and then focus on specific aspect in the code review. And then once the user picks this prompt, get a prompt for review PR with these arguments, it's gonna go trigger this preset prompt based upon the prompt name and go trigger it on the server side and get a response back. So prompts are just this preset templates or workflows that help drive LLM in a particular direction for a particular use case. Any questions so far? Okay. And then, so far we talked about all the primitives from the server to client. So the client is kind of initiating these calls, and the server is responding to those calls, whether it be tools, which is functions, resources, or the prompts. Now we'll talk about the client to server, which is quite interesting. So client to server, the most interesting piece is like, so a good example that I always pull up is a SQL MCP. So in case of SQL MCP, your MCP server, which is sitting somewhere, has zero context of a SQL database, but you want to make use of this server to kind of perform some natural language queries on a SQL database. So but your MCP server doesn't have an LLM or agent. So in this use case, your MCP server could rely on the LLM on the host to make this LLM calls. So the way it works is your server would just trigger a request on the client saying, I would want to use your LLM to perform an operation. So it sends the message and required preferences of params, and then the host would go notify the user. If the user accepts the request and approves it, it goes and makes the LLM call. So the sampling feature helps this MCP server to make use of the LLM on the host to make a call. So it's the other way around. So that's sampling, feature one. And the other two features that the client supports is elicitation and roots. I'll go with roots first. So roots is nothing but set boundary around what resources can be accessed or what resources are not accessed, can't be accessed. So this is just the boundary saying, okay, anything under this can be accessed, or these are the only two routes that can be accessed by the client. And then elicitation is just, in simple terms, it's just like an input form, accepting input information from the user. So as part of this, So in this use case, we are saying, okay, multiple repositories, which one do you want to choose? So it's a question back to the user that is using this LLM MCP client on the host. So the question goes back to the user in terms of a form, if they're using MCP apps, or if we are exposing MCP apps, it'll be some kind of GUI UI on your LLM side. So the user can respond back, providing his or her choice, and then responding back. And then this response goes back to the server, and the server knows what to do based upon this input. So a good example is maybe the user is performing a code review. So the client initiated a tool call on the MCP server, and the code review has been triggered. Now, as part of the code review, the server doesn't have the context of which repo and which MR, etc. Now it'll go trigger the elicitation call on the client, and the client to display a form to the user saying, okay, these are list of repos available and list of MRs in each repo, or one, or like a chained operation. And the client and the user can respond back. And now the client would send this information back to the server. Server can continue its function call based upon this info. So that's elicitation. So now we have covered all the top 6 primitives as part of this MCP server client server communication. So, okay. And then on top of these 6 code primitives, there are other primitives that kind of help with notifying the client. So in case of MCP server, one other interesting cool thing is it supports dynamic updates. So a tool can be dynamically changed on the server side or a resource, and the server can dynamically go notify the client saying an update has been made for the tool. Go fetch the latest tool schema, or go fetch the latest resource information. So that's the notification, and the other notifications are regarding the progress. Since this is streamable and on HTTP, the MCP server can go notify the client the progress of an operation that's happening, etc. So that's where these other features come into picture. So progress notification and cancellation, if someone wants to cancel it, an operation, and log operations. And it standardizes on the pagination with the cursor approach, and the completion and auto completion is also supported, and the ping to check the health, etc. And this is the end-to-end workflow for the use case that we're talking about. What PRs are open in our repo. So very first case, user wants to get an answer on, okay, what are all the open PRs? Sends a request. Even before that, for the user to make a request, the client should have established a connection with the server. That's where the initialization happens. As part of initialization, the client would make few calls, list tools, list resources, list prompts based on what is supported on the server. Now, when the user sends this question, the client goes and finds the appropriate tool and triggers the tool. In this case, list PRs is the tool. And the way the client would know list of all the tools is based upon this initiation and the second call after initiation, list tools. It has list of all the tools, and then based upon that list, it go trigger the appropriate tool. And then the user would go approve of the tool call. Now the tool is executed, and which triggers a function on the MCP server, which responds with a response, and the final output is shared with the user. Okay. Now, pushing an MCP out to production, there are like multiple ways this can be done. One newer way is like MCP-B, which is a package like your DMG on Mac, etc. And the other simplest approach is sending it in simple terms like a jar, which is a local STDO. It's just packaged in some npm, etc. And it can, or a Docker image, etc. And it can just run on user's machine, or user can run it on a server. But other standard approach that's followed across is remote handling, where, oops, other standard approach is the streamable HTTP, where most in case of MCPs where the MCP server needs to be controlled by an organization, or where you need dynamic changes, or where you need stricter authentication and authorization in place, you kind of adopt
Hey,
this
Karthik,
streamable
you're not
HTTP.
sharing your screen. Could you turn your screen
Oh, is
share
it?
back on?
Oh,
Could
okay.
you turn your
Right.
screen share back on?
Sure. Can you see my screen now?
Much
Awesome.
better.
Okay.
Thank you.
Okay, good. Thanks. So yeah, streamable HTTP. So in our use case for Bill, we have been working on a MCP solution to expose Bill's products or Bill's features in terms of an MCP. That way, a client can just go integrate this MCP server into his ChatGPT, etc., and they can make those requests from ChatGPT, saying, "Okay, show me all my vendors, show me top 5 pending payments I would need to pay or I would need to receive, etc., through ChatGPT." And then the authentication means for this is the standard auth supported by MCP, which is OAuth. So that's the other style of deploying MCP. And the fourth option is MCP apps, which is kind of a dynamic GUI interface that is shown on the LLMs or the LLM hosts. For example, in ChatGPT came out with a feature called ChatGPT apps like a year and a half ago. And as part of ChatGPT apps, they would be displaying this preset static GUIs on ChatGPT. And now it has been standardized as MCP apps supported by most of the hosts, Claude and ChatGPT. So these are different ways in which things can be, MCP servers can be packaged and deployed in production. And then jumping into the core important concept, authentication and authorization. So the authorization aspect on MCP is kind of the core thing that helps package different functionalities as an MCP. So you can just expose your DB operations as an MCP server on top of your DB, and you can set all your authentication and authorization based on OAuth on top of your DB through this MCP server. Or other thing that you can use, you can just do proxy authentication and authorization. If you have a API that's well vetted with its own authentication and authorization, your MCP can just be a proxy on top of it, where it can do one-to-one, or it can have an other layer of authentication and authorization on top of your actual existing prediction API layer, API authentication layer. So that's the authentication and authorization. So obviously, if it's running on your local, you'd want to set it as some environment vars, or if it's running on a Mac, you can just set it in keychain, etc. Or you can also trigger an OAuth from your local machine. But most cases, when you're deploying it on server, if a human is not involved, it would be some kind of environment variable or a secret sitting somewhere. But if it's hosted remotely, then it can go through OAuth. It can go through authorization server flow or the client credential flow for in cases where user is not involved. So, and then jumping into the routes. So the very first step of this is like getting all the well-known OAuth resources. So your client would go trigger this call, get all the authorization server URLs or the links, and then based upon that, it would go start triggering the OAuth flow and perform dynamic registration, and then goes to user. User would go initiate the flow, then the OAuth dance back and forth with the authorization code, and in this case, it picks the PKCE, and then the token exchange, and then the token is saved on the client side. So in this case, your host, if all this flow has been triggered from your ChatGPT, your ChatGPT is responsible for holding this token as part of that session, and again, discarding the token, making sure it's securely handled as part of the client server communication session for that chat session. In few cases, these tokens are kind of extended and saved and refreshed for multi-sessions. That way user doesn't have to authenticate for every single chat session with this MCP or do this auth every single time. And yeah, in terms of security on top of this authorization kind of helps us to restrict a few things. But in terms of security, exposing PII data in an API could be fine because the API caller is vetted and the API caller is responsible for making sure this data is properly handled. But exposing any PII or sensitive data to an LLM is tricky because in the same session, your LLM could be interacting with multiple MCPs, and it could just get this PII information from one MCP and share this with another MCP knowingly or unknowingly, which could be bad and catastrophic. So yeah, sharing sensitive or PII data to an LLM or via MCP should be well vetted. In most cases, it should be avoided if not needed. So, and then the release process, as part of this production projects, another step is the release process. Different platforms have different release process in place. For Claude, there's Claude Marketplace, which is easy to release, I guess, because they have less checks and balances in place. But releasing it on ChatGPT is a little intensive. They have a standard process or little elevated process on top of Claude. So, and Gemini has their own way of releasing it. So yeah, when releasing on marketplaces, for it to be searchable and identifiable on these platforms, MCP server need to go through a release process for each platform. And then before I jump into a comparison steps, any questions so far?
Just a,
Okay.
a question. On those marketplaces, they do not distribute SDDIOs, SDDIO MCPs, or it's always remote server.
I think it's always streamable. Yeah, they don't do STDIO, I think. So yes, I think that's true. Yeah, unless something recently changed, but I think that's true.
Okay.
And I think most of these also make sure there is auth layer involved, unless the MCP is pretty open, I guess. So, and I think ChatGPT also makes sure there is these are tied to an organization, and yeah, they do all the background checks before they completely expose the MCP. So I guess so. Yeah. Any other questions?
Yeah, I have a question. How does the LLM learn about these various tools? Is the LLM trained with the tools, or does it somehow know? I like to know what the temperature in St. Louis is, and knows how to go to some sort of source to get the temperature or the weather and so forth.
Yeah. So the tool LLMs are not trained on the tools. Tools are just like the plugins or extensions to an LLM. Tools just give LLM additional functionality or let them be extended to, yeah, what do you call it? Let them be extended to other functionalities across. So yeah, good example, like you mentioned, right? Like the weather tool, that's just an add-on to the LLM, but LLM is not trained upon it. So did I add this workflow? Yes. So in this case, this host plus client, that's where your LLM is sitting. Host is like your Cloud Code, right? Which is a wrapper on top of your LLM. And client is an instance created by your host to make a connection to MCP server. So as part of this, you have an LLM here, and this makes a call. And as part of initializing with this MCP server, it gets list of all the tools. So that's where it learns about the tools available. And then it, based upon the conversation in the session, it makes a judgment call of when to use what tool based upon the conversation and based upon the tool description. It picks a tool and invokes it. So that's how it learns about the tools, and that's when and where it invokes the tool. Did I answer your question?
Yeah, I think I was just wondering, the LLM has to have some sort of tool similar to the one you're using when it's trained, because it has to know what's the current temperature in, name the city or so forth. It has to know how to
Yeah.
go and say, oh yeah, I need to build a request and send it to some sort of temperature getting tool or that sort of thing.
Yeah. I think I understand your question better now. So you're asking if you go put in a prompt in Chat GPT right now saying, okay, what's the weather in St. Louis? It gives you an appropriate answer compared to like 2 years ago. The reason being, I don't think it's trained on the tools, but the process is like it has built-in MCP servers or tools that it has access to. It's making use of those to make the tool call and give you a response back. But yeah, that's true. In that case, it's already built into the host. In this case, I guess we can call it host rather than LLM, because the host in this example being ChatGPT has access to a bunch of tools that would help solve certain needs, like in this case, the weather report. Yeah.
Thank you very much.
Sure. Yeah. Okay, cool.
And I should let people know that if you're online, you can ask a question too. You just need to use the Q&A feature. There's an icon at the bottom right corner that has 9 dots in it. It brings up a menu, and under that menu is the Q&A option. So if the online people have questions, they can type into there. Right now, I'm not seeing anything.
Okay, cool. Okay, I'll jump into the next piece, which is MCP versus skill. So most times, for most people, it's pretty confusing to whether to use skills versus MCP. Skills is still pretty new, I guess. But skills can do most of the stuff that your MCP can also do based upon how you design your skill, etc. So when do you use skills versus when do you use MCP? So think of skills like a manual that is like guiding the user or nudging the LLM to go in a certain direction for a certain use case. So similar to the tools in your MCP, every skill also has a description based upon which your LLM makes a judgment call of when a skill needs to be pulled into its context memory and read and followed versus when to skip it. So yeah, in most cases, every MCP server could also go hand in hand with a skill. That way, a skill is kind of dictating or guiding your LLM of when to use what features in the MCP server. An MCP server could be exposing like 20 different tools, 50 different resources, etc. Having a skill in that case would kind of help your LLM to make better decisions of choosing the tool and the order of your tools. Let's say you have 20 tools and 5 tools are maybe interrelated, maybe they are ordered in a certain way. So all this information can be shared through a skill for that MCP server. So yeah, in most cases, they go hand in hand rather than them competing against each other. And yeah, so skills you kind of define and write skills, but skills don't have any auth involved. So skills are just kind of instructions around it. But your MCP, like we discussed so far, it has multiple use cases. You can have different rules and authentication, authorization, scopes, etc. around it. And you can break it down into different function calls, etc., depending upon what you want to expose as an MCP server. So, and then, yeah, like I was saying, tools and MCPs go hand in hand. It makes a lot of sense in so many use cases. Having a skill tied to your MCP server to make a better decision. So, yeah. In real
Yeah.
world, if you can go ahead.
Yeah, we have a question that came in here from Ram, and he or she asked, how does a host know it needs to query GitHub MCP?
Can you repeat that again?
How does the host know it needs to query for GitHub MCP?
How does the host know it needs to query GitHub MCP? Yes. So in order for the host to know, it's like an extension. So your MCPs are like an extension, right? So you need to install the MCP. As part of installing the MCP, you do the auth process that we were talking about. So once you go install the MCP on your host, then your host has access to MCP. So it'll go make the initialization calls to every MCP that it has access to. And as part of initialization, it has list of all the tools. And then it'll go make that call of based upon the tool description and the session context. It'll go make that call of when to go trigger which tool in the GitHub MCP.
Thanks very much.
Sure. Okay. So most times these marketplaces, in case of Google has a great package mechanism where they go package their skill and MCP as an extension. They call it Google extensions. So when you install this extension, you kind of get this preset instructions in terms of Gemini.md or a skill along with your MCP server. That way your instruction set is kind of helping drive the MCP server or teaching the LLM how to use the MCP servers effectively. So that's a great example of skills going hand in hand with MCP. And the next is when we use MCP versus CLI. This has been a recent question or a debatable question on different fronts. The reason being, in most cases, your LLMs are pre-trained on most of these CLI commands, like your grep or sed or awk, etc. So in that case, if your MCP is already pre-trained, would it add value to have an MCP server do the job if your LLM has already been pre-trained on these commands? So in few cases, it makes sense to go with CLI because in cases where your LLM has been pre-trained with basic Linux commands, etc. But in scenarios where like an external API, like a GitHub API or a Atlassian API, Jira connectors, or your Confluence connectors, etc., where the service provider could change things dynamically, your LLM might be outdated, and running these things through CLI might consume more context window and might use more tokens. The reason being your CLI is not well versed with the response payload and the schema of the response from these tools, and it might go generate its own scripts or start going in loop to go parse the schema to get the information that you're looking for out of the response. So it might be more expensive going with CLI in those cases. So in those cases, MCP wins where it's preset with a structured output. It knows what to look for, where, why, when, etc. So that's the difference between MCP versus CLI, when to use what. There's some overlapping use cases where you can use one versus other. It doesn't matter. In cases where maybe you have a predefined CLI tool for your internal developer productivity, and these tools are pretty minimal and not verbose enough. So yeah, in that case, maybe you can build an MCP on top of your internal her tools, or maybe just expose the CLI. So yeah, an agent can go use the CLI. And then, yeah, different types of MCPs. MCPs can be broken down into n number of types depending upon how you want to design it. This is still pretty vague. So like we were talking about, most basic use case is creating an MCP wrapper around API layer. And the other use case maybe for internal access is data access, creating an MCP server on top of your Postgres or MySQL or any other database for internal developer use cases. And other is file system and Playwright. Playwright has one of the best MCP servers out there. So for other productivity tools like your Xcode for your iOS development, etc. So yeah, so different ways. The most interesting way that's out there right now is agent as server. So you can kind of have your agents behind your tools exposed via MCPs. So when you trigger a tool call via your MCP, you can indirectly go trigger an agent or go trigger a workflow somewhere or go trigger an async fire and forget process. So all these have been pretty fascinating. So these are other things that you can do with an MCP. Different ways you can build an MCP or different use cases. So once you start building and once you go expose your MCPs out in the world, so there are some edge cases that need to be addressed. So last year when MCPs came out, GitHub had their MCP out and Git had their MCP out. So as part of GitHub MCP, they had a bunch of tools, around 30, 40 different tools. But at that time, most of the coding solutions or the coding agents like the Copilot or Copilot was the only major one, I guess. Copilot or your Cloud Code. These weren't supporting MCP tools more than 70. If you had more than 70 tools, it'll just block your session until you go remove certain number of tools to make sure you're within that limit. Because after a point, if the number of tools are more in your context, your LLM tends to hallucinate. It might not end up picking the right tool for the right job. It might be picking wrong tools, or it might fail to pick the tool. So to avoid these things, there are different ways to avoid this. So one is tool discovery and tool search. So these are just a few options. This area is still evolving, but the ideal approach is just exposing the minimal set of tools that are viable for the use case. If for some reason there needs to be a lot more tools, so then that's where you kind of look into or evaluate the advanced approaches, in which case you can go with the tool discovery or tool search approach, or you can kind of break your MCP server into tiny MCP servers by domain, or you can have a tree structured MCP tool discovery, which is more efficient. So yeah, one of these options, but again, this is still evolving. Again, the best case is to have minimum set of useful tools exposed rather than you exposing a ton of tools that most people don't use. So, and then the other concept around MCP is the gateway. Just like API gateway and MCP gateway. So MCP gateway, think of it like your organization would only want to expose a handful of MCP servers that were vetted by the organization instead of it giving open access to all the employees. So that's where MCP gateway comes into picture, where your organization would pre-vet, pre-auth, everything is done within your gateway. They have their own governance, traceability, etc. within the gateway, handled in the gateway, and the developers, internal developers within the organization would have some sort of marketplace where they can go pick and choose the gateway or go identify, discover all the MCPs being exposed, and then go integrate them into their coding solutions or their LLM solutions. So that's the use case of MCP gateway. Any questions?
Maybe that's the pattern that you really need for not having to load a lot of tools. Just have a locally deployed MCP gateway across, because you end up exposing all of the endpoints, but you only have one MCP server, but you expose all the capabilities that are encapsulated across all the servers.
Yes, but even in that case, yeah, it's just the pick and choose of the tools that you need, right? Though you're exposing one MCP server as a gateway or entry point, you might still have 100 to 100 tools being exposed from this virtual MCP servers that are behind this gateway. So yeah, it still gets tricky. You still would have the same problem. Yeah. But like you said, yeah, for every use case when you're integrating with this gateway or the service, yeah, you should always pick and choose, make sure you have right tools for your session or the context that you're using. So it helps for preset workflows, for predetermined workflows, like a harness-based or a workflow-based development workflows. It helps a lot because you know that you need, okay, I need GitHub MCP, and from GitHub MCP, I only need these set of tools for my use case for a code review agent, etc. Or maybe for production triage agents, you need maybe a New Relic MCP with bunch of tools from New Relic MCP rather than giving it access to all the MCPs and tools. So yeah, for predetermined things, it's a lot easier. But yeah.
How do you manage throttling and
Sorry, I couldn't hear you.
How do you manage throttling and rate limiting? Okay.
How do we manage throttling, and what's the other one?
Rate limiting.
Rate limiting and throttling?
Yeah.
Yeah.
Yep.
So yeah. So when you have so in case of I think that problem only arises for HTTP based MCP solutions, right? If your transport is HTTP streamable extra, for STDI, I think it's just running on your machine, so it's fine. For streamable, most of these MCP solutions are behind an API gateway, because end of the day, that's just a HTTP call. So you would be having it behind your API gateway. So your API gateway would handle first layer of throttling or rate limiting. And then on your MCP server, if you need anything customized, then you can do it on your MCP server per tool call, etc. So yeah, it's like how you handle it with API, nothing fancier or custom just for MCP. Yeah.
And how do you handle the stateful session in the MCP?
I'm guessing you're asking how do we handle stateful calls, right?
Yeah. Like, is it a sticky session? Like how does the gateway kind of handle that session?
Yeah. So it's up to the implementation. In most cases, I guess it's like your microservice, right? You can just design it being a stateful microservice or a stateless microservice, or your resources could be, some resources could be stateful, some could be stateless. So in the same regard, yeah, this is no different. Your tools can be stateful versus stateless. Yeah, if you need a state, you just go versus state and maintain state somewhere, right? Yeah, this is no different from your regular REST resources for HTTP streamable. Yeah.
I was talking about the client sessions.
Which session was it? Sorry.
Client sessions, so MCPs are supposedly available to stateful settings, right? I mean, if a client connects to the MCP gateway, how do you maintain a stateful section for any MCP calls?
Oh, you mean on the client side, not the server side?
Yes.
Okay. On the client side, your client is supposed to maintain that session. So I'm guessing in most cases, you need the session open for, let's say for a LLM chat session, you trigger an MCP call and a tool call, and you initiate a session through MCP client and server. So you need to maintain that auth token or the access token somewhere for that session. So that is handled on the MCP client side. If it's like a host like Claude or ChatGPT, they handle it inbuilt. But if you're building a client from scratch for a random use case, then the client owner, whoever is maintaining this client, are responsible to handle that. So I have an example after this. I can show you a little in that. Yeah. I have a custom client that I built for demo, so I can jump into that real quick. So let me jump into this. I hope it's still running. Yeah. So this is a MCP client. So I just built it so you can see the communication between the client and server clearly. You know what calls are being made and what response we are getting from the server. And then there is this demo application. So here the goal is triggering a preset prompt, and your client would go initiate this MCP server. This is a coding agent MCP server sort of thing. There's a coding agent behind this MCP server. It goes and makes the code changes in this React application. So in this case, we have like default theme being brand and React queries enabled and Lucid icons are disabled. So let's go pick this MCP server. Let's start with the health check. So when we triggered the health check, it made a call to get list of all the prompts. As part of this, it got list of all the prompts. As part of this, it got this prompt and the description for the prompt. And it also made a call with for the list of resources. It got a response saying, okay, it has access to these resources, this JavaScript file. And it also made a call for list of tools. And it said there is a tool for modifying the file or making changes to the file. So now your LLM knows everything that it needs to know via this MCP client call. So it knows the prompt, it knows the resources that it has access to, and it knows the functions that it has access to, the tools. Now it will pick the preset prompt. This prompt says, okay, start the modernization process for a legacy app, etc. So it has a preset prompt behind the scenes. We just go trigger this prompt. As part of this, it needs certain inputs. So instead of this brand theme, we pick dark, and we just disable both React and Lucid icons and trigger this. And give me 1 second.
Did we lose him?
Hey, sorry for that. My son needed something. So, okay. So now we just triggered this prompt, and let's see what happened on this prompt call. It made a bunch of calls. Okay. Okay, as part of this prompt call, it made this tool list prompt get resource. Okay, so it got the prompt, it made this prompt call, and as part of this, it's reading the resources, it's getting all the resource information. So it's getting it in the text format, and it's getting this JavaScript file in the response from the server. It got the file. Now it's passing that to an LLM. The LLM is reviewing it and making changes. Now it made the changes, and it's triggering this tool call, which is write and modify the file. As part of this, the server received this request for the tool call, and then it's sending the status updates notification messages saying preparing, and then it's saying, okay, it's prepared to write, make changes. It's making changes in 3 blocks or 3 steps. So it's updating it with the progress. This is the progress primitive that we saw. And yeah, it keeps updating the progress. It finishes it finally, and it says it's done. And now it calls the sampling. Sampling is where your server is using the LLM. So it's calling the sampling for the code review. After the file was modified, it sent it back to your client for code review. So the LLM on your client side is reviewing the code through this sampling primitive. And then you get notification saying, okay, successfully made changes and pushed the changes and committed the changes. So that's one example. In this, go ahead. Sorry, someone was asking something.
Looking at the code and it's actually sending from the MCP server the JavaScript to be used, and then it pushes ask for a pull request on that same. Is that the workflow of this MCP tool?
Exactly. That's the use case here. In this use case, your MCP client, the host, which has access to an LLM, makes a call to the server. This is just a coding agent server that just has access to these files, what files need to be changed. So yes, it got access to the content of the file. It made changes. It sent it back, asking it to go make changes and update it on the server side. So yeah, that's the workflow. Yes.
Cool.
And then for the second example, we can pick this API Explorer. So in this case, Open API spec pet store. Okay, let's pick this Open API spec here. So we want to expose an MCP server on top of Open API spec. So once you load this MCP server, you have a bunch of tools. One being loading the spec. So you can put in any Open API spec for any API. And once you load the spec, it's making these calls. So I did a tool call, loading the spec. It sent a notification saying, okay, then let's call the list endpoints, execute tool call. So we call list endpoints after loading the spec. Now it returned back and said, okay, there are 19 endpoints in this, 19 resources. I don't know if it has the resource ID, but yeah. Get endpoint details. So you put in an endpoint, you get details. So these are all the tool calls, which is like your request and response. You're triggering a function call on the server. You're getting a response this way. So this is the tool call for the second MCP. And this third one is pretty interesting. This is the SQL Explorer MCP. I have a sample database for this. Okay, so in this case, okay, it did the exact same thing during the initiation. It's trying to get list of all the prompts. It got the first prompt saying explore database. That's the only prompt. And now it's trying to get list of resources. It has a few resources, like one with DB connection, DB query, and the connection manager, etc. And then it's doing, okay, list out all the tools, and then, sorry, it's just repeating. Okay, now let's do this connect to a database, list connections, execute. So it has one connection established by default, which is a demo SQLite connection. So in theory, this is a open source project that I created, an MCP server. It supports any kind of database, and you can do natural language queries with any database. And then now we have this DB. So let's say, okay, for this DB connection, can you go describe this database? So when we said describe the database, it said, okay, it has an orders table, column 5, row 6, and then products, and then users. So yeah. So in this case, I was trying to show you, or I'm trying to explain different primitives, which is the interaction between the client and server, and also the server and client that's happening here. So in this case, the very first step as part of initialization, prompts are getting listed, and your client is getting list of prompts, list of resources, list of tools available. And then it's making a tool call where it's invoking a function or a tool on the server side, and your tool would just go respond based upon it. And then you can also put a natural language query saying how many users are in the DB. So I hope this works. Okay, so it generated your SQL Explorer generate. Okay. So in this case, it's kind of running this. So it's coming up with this query and instructions to go come up with a query based upon the user's natural language input. And this gets sent to an LLM, which should convert it to a query, and that query would run against your database and you would get a response. based upon this sampling feature, sampling primitive. So yeah, you can see that in the logs, it's saying, okay, generate SQL query to answer the question from the user, and it gave it the tables that are related to it and its schema structure, and it's saying, okay, come up with a query around this. So this is the thing that's being sent to the LLM for natural language to query conversion. So okay, jumping back to the presentation. Okay, yes, that's the last step. So any questions?
Yeah, there's a question here that was posed by Anonymous, or he or she says thanks.
Okay.
Let's assume I add GitHub, Jira, MCP servers, and say Claude. Now, if I make an LLM call, are all the tools from both GitHub and Jira sent on each call?
Yes, they are sent on each call. Yes, let me show that here. That's a good question. Okay, so if I pick this, do I have, yeah, I think I have my Copilot here. Okay, so this is where you can see that by default, once you pick and make choices. So in this case, I have a bunch of MCP servers. I have Context 7, the SQL MCP server, and others around Jupyter, Python, etc., and this API Explorer. So by default, I have selected every possible tool within each and every one of these MCP servers. So this is gonna go blot my context window. It's gonna send the MCP name, tool name, and its description to your LLM every single time. So for every single session, to be precise. And yeah, if after a point, after a tool count, if the tool counts are 70 or 80, after a point, yeah, the performance degrades on your LLM. If you're using a decent basic model, not the very expensive model. So yeah. So it's always better to be cautious and strip out the MCPs or the tools that you don't need for your use case or your session. Any other questions?
Those are all the questions I see online. Are there any more in the training room?
Any other questions?
No.
All right. Well,
Oh,
got one?
I just thought of, you said that some of the stuff that you showed is you've open sourced.
Yes, a couple, I guess. I don't think I have open source this API Explorer yet. I'm still working on it, but the SQL Explorer is open source. Yeah, there's an NPM package around it. So yeah, you should be able to install it.
What kind of frameworks are you using for?
Sorry, I just heard what framework.
Did it die?
Do you mind repeating again? Your voice is not audible.
Check. Can you hear us now? Can you hear us?
Yes, I can hear you. Yes, yeah. Go ahead.
Okay, what kind of frameworks do you suggest for creation of the MCP servers from, let's say, the OpenAI API stack that you just used? Are there some API packages, or scaffolds and MCP servers?
Okay, sorry if I understood it correctly. Your voice was breaking. But what was the tech stack I used to build the MCP server? Was that it?
Yeah, I mean, the question was, do you have any frameworks that you're currently using in your application or otherwise to publish an MCP server from, let's say, an open API spec to scaffold it?
Like an open API spec.
Or an SDK.
Yeah.
Okay, so yes, yeah, MCP has a library for wrapping up like a SDK just to wrap up all the MCP boilerplate. So yeah, I mostly use TypeScript, so I can quickly show you this. Yeah, so if you Yeah, I'll just quickly show you a couple tools. So this is the self-registering tools. So let me go here for DB. So these are all the tools that I have. So if I go to one of these tools, a connection, I guess, yeah. Describe schema, this is a better one. So if you look here, we use this Zod framework for the structured schema. So you see that everywhere here, and yeah, we are using TypeScript, and this types.js has this tool registration through which we do register tool and stuff, but I don't remember the exact library name. Let's see. Yeah, model context protocol is the library, I guess. Yeah. Yeah, that's the one that gets used. I think they also have a Java version, etc. So yeah.
There's also bindings for.
Sorry, I missed that. But yeah, you can also build the exact same one in Java too. Yeah.
Yeah, the
But-
comment was there also bindings for Python.
Sorry, yeah, your voice is so yeah.
The comment was that there are also bindings for Python. It was just a comment.
Yeah.
All right. Any more questions in the room? Anything else online there, Bruce?
Yes,
Ted?
we have a question from Ram. Can you please explain sampling? And he puts that in quotes. A sampling call back from MCP server. Didn't understand that well.
Awesome. Yeah, that's a great question. Yeah, sampling is surely confusing. So sampling, so your okay, let me go here. Okay, so if you look at this visual, so your host, which could be your Claude desktop or your VS Code Copilot, whatever, right? That's a wrapper on your LLM. So think of your host as your LLM wrapper. Your host has this client connection that's being made to the MCP server. Your MCP server has no access to LLM. Given that your MCP server has no access to LLM, if you want, you can have LLM access to MCP. But let's take a scenario where your MCP server doesn't have access to an LLM. But if your MCP server needs to make a LLM call to maybe go change the tone of something, or to maybe go do a code review of a piece of code, your MCP server can go piggyback the LLM on your host to make an LLM call saying, okay, this is my token budget. Within this 5,000 tokens, can you go make an LLM call? That way, when your MCP server makes the sampling call to your host, the user that's managing the host would see a message saying, do you want to approve or deny? This MCP server would want to make an LLM call on your behalf. Do you want to approve or deny? Let's say as a user, you're approving the call. That would go trigger this call with your LLM, get a response from LLM, send it back to MCP server. And based upon that information, your MCP server might do something else. So this whole process from your server to client LLM is the sampling, is the concept of sampling. So in the example I was showing you for code review, right? So in this case, let me just refresh this. So in this example, I am just making this code change. This example has a sampling call made, so that's the reason I picked this one. So here, if you see this, your client made a code change and sent the file back to MCP server. Your MCP server updated the file, and now it wants to perform a code review, but your MCP server doesn't have access to LLM. So that's where it's kind of triggering a sampling request call to your client. As part of this sampling call, it's saying review this modernized React component as a senior architect, whatnot, etc. Follow the standards, etc. And it sent it the code sample. And it's saying, okay, maximum tokens to be used for this is 2000. It sent this request, or it triggered that call on your client. Now your client would go pass this on to the LLM, and your LLM would go process it and send the response back to your MCP server saying, okay, things are good. I don't know. Did we write it? Someone successfully wrote one as well. I don't know. Maybe this was dropped, but yeah. So this is where your server is making this LLM call to your client, and your client would just go, your client LLM would just go process it and go respond back to the server. So that's the use case.
Karthik, you need to share your screen again. We
Oh,
kind of lost
damn.
about the last half of that.
That's embarrassing. Okay. Okay, cool. So I was talking about this picture here where you have your host, which has the LLM, MCP server making a call to the LLM, getting LLM information, etc. So this is the flow I was showing as part of the code review. So up here where your MCP server, after making a file change, if it wants to talk to an LLM, it doesn't have access to an LLM, but your client or host has an LLM. So it triggers this call saying sampling create message with this information saying, okay, review this modern React component as etc. etc. That triggers a call on your LLM on the client host side LLM, and that would respond back to the server. So sampling is just your MCP server making use of the LLM on the client side.
Okay, that's all the questions here for the folks online. Is there anything else in the room?
Last call for questions. I think we're good.
Awesome.
I'm gonna switch on the light. Let's say thanks to our speaker.
Yeah, this is the part where you generally hear a big round of applause.
And I neglected to say this at the beginning, but Karthik also sponsored the pizza for tonight. So we should thank him again for the pizza.
Thanks, guys. Yeah.
Thanks again. The pizza was excellent. All right. So at
Sure it
this
was.
point, I think I'll turn off the recording
Bruce.
and then we'll move to the raffle.
All right. Sounds good.
Let me hit the stop button if I can find it.